This question is more of a scale and a model question. So we talked about actual over model a lot in class. We're going to read this question and use a proportion to solve. The scale on a map that Lynn is looking at is 25 miles for every 4 centimeters. If Lynn is going to travel to Cincinnati, which is 288 miles away, how far would that be on a map? So on the map that she's looking at is what it's talking about. So we have this ratio of 25 miles, 4 centimeters. So I'm going to use this ratio and set up a proportion with it. So 25 miles, and that's 4 centimeters on the map she's looking at. Now we know that Cincinnati is actually 288 miles away. Now this question is different than the one that we had before. I'm putting this one on the top because with the proportions, with this equal sign, I need to be consistent with how I set this up. Miles and miles are on the top, centimeters and centimeters were going to be on the bottom. We don't know how many centimeters that actually is on Lynn's map, so I'm going to use the variable x. So again, this problem is different than number 7 because these ones we were multiplying the fractions. In this one we have a proportion, so we actually are keeping the miles and the miles on the top. This is going to be centimeters. This will be centimeters on the bottom as well. Okay, now that because this is a proportion, how we're actually going to solve is by cross multiplying. So I'm going to do 25 times x is equal to 4 times 288. And let's actually write what this is. 25 times x is going to give me 25x and equals 4 times 288. I wanted to just type it like that so you guys know that's what I'm doing. 25x is equal to, and then let's actually figure that out. 4 times 288 is 1,152. Now we're trying to isolate the x, so I'm going to divide by 25 on both sides. When I do that, I'm going to get x is equal to 46.08, and that would be centimeters. So on the map that Lynn is looking at, from the school to Cincinnati, it's going to be 46.08 centimeters. Okay. Moving on to the next standard, it's modeling with expressions. So we are going to write an expression for each situation in numbers 9, 10, and 11. This first one is very mathematical. It says 2 times a number decreased by 7. So we are reading this as it is and then trying to write an expression. So 2 times, that means 2 multiplied by a number. We don't know what that number is, so you can use any variable that you want to. I'm just going to use x for this case. So 2 times a number, it's going to be 2x. And then this next word indicates another operation. It says decreased by 7. Decreased means subtraction. So I'm going to subtract 7 in this case. So my expression is going to be 2x minus 7. All right, number 10. The sum of 7 and half a number. Sum indicates addition, so I'm going to say the addition of 7 and half a number. So 7 plus, and then half a number. We don't know what the number is, so again we can use whatever variable we want to, but we need to indicate half. Some of you will use a fraction and just write half as a fraction, like 1/2, 1 over 2. Because my computer option that I'm typing, I'm going to say 0.5, because 0.5 is also a half. So half a number, which would be x. So that's our expression for number 10. Number 11. Sarah earns $3 per hour for chores and a $15 as a bonus. So this is the rate, so $3 per hour for her chores. So that per hour indicates that there's going to be multiplication times the number of hours. So for this one, I'm going to use h as my variable, so 3h, so 3 times the number of hours that she works, and that bonus of $15. It's a nice bonus. Okay, so that's it for writing an expression from words. Now we're over here and we're going to use this expression and we're going to highlight things that are needing to be identified. So list the coefficient or coefficients. In this case, coefficient is going to, actually in all cases, coefficients are the numbers in front of the variable. So I'm going to highlight these, and I'm going to be very particular how I do this. We talked about this in class. A lot of times students forget the symbol that goes in front of the number. The coefficients in this question are 4, -5, and -2. I'm separating these with commas so that it doesn't look like a subtraction problem. That's really important, because if you didn't have those, it would look like 4 minus 5 minus 2, and that is not the same thing. We are listing the coefficients. We're listing the numbers in front of the variables, including their signs. Okay, now I'm going to erase the highlights because we're going to talk about something else. In this next part, it says, list the constants. So the constant is anything that does not have a variable, and there's only one term in this whole problem that does not have a variable, and that is 13. So 13 is my only constant in this expression. Okay, last question says list the terms. Terms are separated by subtraction and addition. So I'm going to, actually I'll continue to highlight, that's fine. I have a term here, 4x. I'm going to change the color so you guys can see the difference. I have a term -5y, that's a term. 13 is a term, and then -2z is a term. So let's go ahead and list those. I'm going to separate them with commas because otherwise it looks like I'm just rewriting the problem. So 4x is a term, -5y is a term, that positive 13 is a term, and -2z is also a term. Okay, so that's it for the 2.1 modeling with expressions. Okay, 2.2, creating and solving equations. I'm going to read this question several times. We're going to write an equation, and then we're going to also solve. Number 15, Jeff and Alexis go out to dinner. They purchase nachos for $7 and 2 entrees at the same price for a total of $33. Write an equation modeling the situation and solve for the price of 1 entree. Okay, so it's about Jeff and Alexis going to dinner. They purchase nachos and 2 entrees for a total of $33. So I'm thinking about the nachos. The nachos are $7, so we have that 7, and then plus their 2 entrees. We don't know how much they cost, so $7 plus the 2x, so 2 times whatever that price is. And then in total, they spend $33. So in total is telling me that I have that equal sign there and have them added together equaling the $33. Now we're going to use our inverse operations in order to solve. I'm trying to isolate the x, so we need to first remove this 7 from each side. Since it's a positive number, I'm going to subtract 7 from both sides. When I do that, I get this result of 2x is equal to 26. Lastly, I'm going to divide both sides by 2 so that I can get the x term by itself. And then I can simplify that and find that x is equal to 13. Now this means that each entree was $13. And I like to write this in a complete sentence because it actually makes sense of the problem and says, hey, x stood for the entree price, and here it is. Okay, next up. We have this question, and it's about Trisha. She's trying to decide which gym she should become a member. Anytime Fitness has an initial fee of $165 and is $30 per month. The Nolensville Recreational Center has a $60 initial fee and is $65 per month. How many months until two gyms cost the same amount of money? Okay, so we have 2 different gyms here, Anytime Fitness and the Nolensville Rec Center. So Anytime Fitness, they have that initial fee. So initial fee means you're adding that. So like right when you sign up, you have this fee of $165. However, after that, it's $30 per month. So $30 per month. This per month is indicating to me that there's going to be some multiplication happening, but we don't know how many months that is. I'm going to go ahead and say 30M. I'm going to go over here a little bit. Okay, now the Nolensville Rec Center. It has an initial fee of $60, And then it's $65 per month. So again, 65 per month indicates that the variable is going to be with that term. Continuing to read this question, it says, when will these two gems cost the same amount? When it says the same amount, I know that I want to set them equal to each other because I want to know when they're equal to each other. Okay, so now we have our equation, and now we need to solve. We have variables on both sides in this case, and that's different than previous questions. We need to get our variables to the same side. Now I have a 30m and I have a 65m. I could move either one of them, but it's going to be easier for me to move the 30m because it's smaller. So plus 30m, this inverse operation to addition is subtraction. So I'm going to subtract 30m here, and then I'm going to subtract 30m here. That's going to leave me with 165 is equal to 60 plus, and then 65 minus 30 is going to give me 35m. Continuing to solve here, I'm trying to isolate this m, so I need to subtract the 60 from both sides of my equal sign. And now that leaves me with 105 is equal to 35m. My last step in solving is to divide both sides by 35 to isolate that m. So I'm doing that, divide by 35. I get that m is equal to 3. So at 3 months, the two gems cost the same. There we are. Okay, next page. And these ones you are solving for a variable. So this is the next standard, solving for a variable. Here is our equation. We have xy plus z is equal to 9. We are trying to solve for z. So I'm going to highlight z, and I did this when I was in class too. Highlighting the z, I can see that I need to move this term to the other side. Now, because there's no symbol in front of this xy, it's understood that it's positive. So to move it to the other side, I need to subtract it. So I'm going to subtract xy there, subtract xy here. Now, I cannot combine 9 minus xy because there's variables in one of them and not in the other. So I'm just going to rewrite it. My xy's are going to cancel on this side, so I'm left with z is equal to, and then I'm going to write 9 minus xy and just leave it just like that. That is my solution. Okay, number 18, we'll go over here. Solve for x. So we're solving for this x term. I have two steps involved here. Before I can worry about the 3, do not worry about the 3 first. I need to think about this plus y. What is the inverse to adding y? That's subtracting y. So I need to subtract y from both sides of the equal sign. When I do that, that leaves me with 3x is equal to, and I can't combine the z and the y because they're different variables, so I'm just going to write z minus y. Last step is divide by 3 on both sides. So divide by 3, and I'm going to write this in a different way because I'm going to get my x by itself. So I'm going to write z minus y, and then I'm just going to use a bar like this, and then I'm going to write the 3 on the bottom. And then I'm just going to leave it like that. I can't simplify anything about this, just leave it. Boom, there's your answer. Okay, last question. On this page, I'm going to solve for h. Because I'm solving for the h, I need to move the 2a first. So I'm going to subtract 2a from both sides because the 2a is positive. So subtraction is the inverse operation. So when I do that, I can't combine s and 2a. So I'm just going to say s minus 2a. Now that is equal to bh. I'm still trying to solve for the h, and now this b is tied to that by multiplication. So I need to divide both sides by b.